Welcome back. This is Chapter 14 on acids and bases, and we're to Section 4.3, which is on strengths of acid and bases. If you'll remember from last lecture, we saw that if you were to have an acid that's able to donate a proton, what's left over when it donates that proton is considered to be its conjugate base. And if you have a strong acid that gives away a proton and its conjugate base is going to be a very weak base. And if you have a strong base that receives a proton from an acid, it will become a very weak acid. Okay, so you're going to see that the relative strength of the acid and its conjugate, or the base and its conjugate, are inverse. So now we have to ask, what does it mean to be strong? Okay. So the strength of an acid is not whether it will burn you. The strength of an acid is basically, does it completely break apart when you put it in water? So an acid, if you'll remember hydronium, a proton, if you were to give a proton and in water, it reacts with a water molecule to become a hydronium ion, which is an H3O plus ion. So water receives protons very readily, and so water can act like a base in that case. So if you put anything that's acidic in water, the water will act as a base and receive those protons from the acid. So it breaks completely apart. So a strong acid essentially when you put an acid in water, it breaks apart completely. All the protons will break apart from whatever their conjugate base will be. Okay, so whatever type of molecule that is. So a strong acid ionizes 100%. Okay, a weak acid doesn't. That's the difference. So it's not that a weak acid isn't dangerous and a strong acid is very dangerous. A strong acid breaks apart or dissociates into H plus and then some negative part of whatever acid that happens to be, whatever is negative is left over, the conjugate base. So strength of acids is whether or not it completely breaks apart into ions. So a strong acid ionizes completely, a weak acid doesn't. Do you remember electrolytes? An electrolyte is anything that a strong electrolyte was anything that broke apart completely into positives and negatives, so that you would end up with a current that could go through that solution. Well, a strong acid is a strong electrolyte. And you're going to see that there's only a few. There's about 6 or 7 that you would have to memorize that are strong acids. Every other kind of acid is considered weak. It doesn't break apart completely. Okay. So here's an example of a strong acid. Hydrochloric acid, HCl, is strong and it completely dissociates. It completely breaks apart. Acetic acid, which is what is in vinegar, contains only a few ions, mostly molecules. So it doesn't break apart very much. So it's a weak acid. So let's look back here. I told you that there was a few that you would memorize. This is the list. There's really only a few. You're going to have perchloric acid, HCl4, sulfuric acid, H2SO4, hydroiodic, hydrobromic, hydrochloric, which remember that's hydrogen plus the group 7, and then nitric, so made out of nitrate. Those are strong. If you have those, they'll break apart completely into ions. Anything else, any other acid you would have, is considered a weak acid. These are what you have left over when you give away your H. So this would be the base. If this is a strong acid and I give away the H, the chlorate or the perchlorate ion that's left over is a weak base. Okay, we're going to see that later. Weak acids are made up mostly of the molecules. Only a little bit of the proton and electrons, or the negative and positive elements, are left in the water. So you've got lots more weak acids than you do strong acids. Strong bases are mostly hydroxides. Okay, so when you were to take a pH, we'll talk about pH later, of something, and it's very high, towards 14, then you know that's a strong base. And your peroxides especially um, are strong bases. And remember, strong doesn't mean how potent they are. It's whether or not they completely dissociate. So when you put them in water, they will. Now, remember, hydroxide was on the side of the pool. It was high and dry. But anything in group one is considered to be always in the pool. Okay? And there is another one you kind of have to remember, because lithium, remembers, in group one, sodium's in group one, potassium's in group one. All of these would be in the pool, and so they would dissolve in water. Barium hydroxide is also a strong hydroxide. They will dissociate completely. Okay. Weak bases are ones that, when you put them in water, are mostly the molecule. They don't break apart into the ions, and so they would be considered weak bases. Okay. I hope this helps. This is a lot easier than the last section, and I'll see you in class.